Hello, and welcome. Welcome to this quiet space we are creating together. Welcome to this journey into the mountains, and into the landscape of your own mind. You have arrived here seeking rest. Perhaps the day has been long. Perhaps your thoughts have been busy, circling and spiraling in the way thoughts do when evening comes. Perhaps you simply want to drift away to a peaceful place. Whatever brought you here, you are welcome. You are safe. You are exactly where you need to be. Tonight, we will travel together into the mountains. But this is not a journey of effort or striving. This is a journey of release, of letting go, of allowing yourself to be carried on a gentle current of words into sleep. The mountains we will visit exist both in the physical world and in the quiet spaces of your mind. They are real and they are metaphor. They are stone and they are story. Take a moment now to settle yourself. Feel the surface beneath you, supporting your weight completely. You do not need to hold yourself up. You can let go. Feel the texture of whatever covers you, soft against your skin. Notice the temperature of the air, cool or warm. Notice your breath, moving in and out, without any effort from you. Your body knows how to breathe. You can trust it. Let your eyes close, if they are not closed already. Or if you prefer, let them soften, not focusing on anything in particular, just resting. There is nothing you need to see right now. Nothing you need to do. Nowhere you need to be except right here, right now, in this moment. As we begin, I want to tell you what this journey will be. For the next several hours, you will hear about mountains and about your brain. You will hear about the remarkable relationship between these high places of earth and the intricate landscape of your mind. But these are not facts to memorize or lessons to learn. They are simply a gentle stream of words, a soft current to carry you into deeper and deeper rest. You do not need to follow every word. You do not need to understand everything. In fact, the less you try to follow, the better. Let the words wash over you like water over stones in a mountain stream. Some words will catch your attention. Others will flow past unnoticed. Both are perfect. There is no right way to listen to this. There is only your way, in this moment. The story we will tell is an ancient one. It is the story of why mountains call to us, why we have always been drawn to high places, why something in us responds when we see peaks against the sky. This story is written in your neural pathways, in the very structure of your brain. You already know this story, even if you have never thought about it consciously. Tonight, we are simply remembering together. Mountains have been part of the human experience for as long as there have been humans. Our earliest ancestors looked up at mountains with wonder and with wisdom. They knew that high ground meant safety. They knew that mountains brought water. They knew that peaks marked the landscape, providing landmarks to navigate by. And so, over countless generations, the human brain learned to respond to mountains, learned to find in them something essential. You carry this ancient knowledge in your neurons. When you see a mountain, even in a photograph, something deep within you stirs. This is not random. This is not learned in your individual lifetime. This is ancestral memory, genetic memory, the accumulated wisdom of millions of years of evolution speaking through the architecture of your brain. Tonight, as you rest and drift towards sleep, we will explore this relationship. we will walk together through the ways that mountains affect your mind, your emotions, your sense of self. We will discover how altitude changes your chemistry, how vast views alter your perspective, how stone and sky and thin air create specific states of consciousness. But remember, you do not need to work at this. You do not need to try to understand or remember. Let yourself be passive, receptive, open. Let the words come to you rather than reaching for them. This is not a lesson. This is a lullaby, a meditation, a gentle companion for your journey into sleep. As we talk about mountains and brains, neurons and chemicals, you might wonder why these topics for sleep. The answer is simple. These are stories of how you work, of how your mind creates your experience of the world. And there is something deeply soothing in understanding yourself, in recognizing the patterns that shape your consciousness. It is like finally understanding the plot of a story you have been living without knowing the narrative. There is peace in that recognition. Moreover, mountains themselves are peaceful. They are the still points in our spinning world. They do not rush. They do not worry. They simply are, present and patient, weathering storms and seasons with imperturbable calm. And tonight, as we explore mountains together, some of that mountain calm will seep into you. You will begin to embody the qualities we discuss. You will become, in a sense, mountain-like, still, grounded, peaceful, patient. Your breath is already slowing, matching the pace of these words. Your muscles are already releasing, letting go of the tensions they have held. Your mind is already quieting, like wind settling into stillness after a storm. This is natural. This is right. This is exactly what we want. The journey ahead is long, and that is intentional. We have hours together, you and I, hours of gentle words, flowing thoughts, mountain wisdom. You will likely not hear all of it. You will likely drift in and out of consciousness, aware of words sometimes, gone into sleep at other times. This is perfect. This is the goal. Let yourself drift. Let yourself float on the current of this narration, sometimes hearing, sometimes sleeping, always safe, always held. Think for a moment about what mountains are. They are the oldest things on earth that we can see and touch. The stone beneath your hand on a mountain summit may be hundreds of millions of years old. It was here before anything you can imagine. It will be here after everything you know is gone. There is something profoundly reassuring in this deep time. Your worries, your concerns, your problems, they are real, yes, but they are also temporary, fleeting, like clouds passing over a peak. The mountain remains. Tonight, you can borrow some of that mountain permanence. You can rest in the knowledge that beneath the changing surface of your life, there is something solid and enduring. Your essential self, like the mountain, remains. Circumstances change, emotions shift, thoughts come and go, but underneath, you are still here. Solid. Real. Enduring. As we prepare to begin our journey in earnest, I invite you to imagine a mountain. It can be a mountain you know, a mountain you have seen in photographs, or a mountain that exists only in your imagination. It does not matter. Just picture a peak, rising from the earth, reaching toward the sky. See its shape against the horizon. Notice the way light falls across its slopes. See the color of the stone, the patches of snow perhaps, the the dark green of trees on the lower reaches. This mountain is waiting for you. It has always been waiting for you. It is patient, the way mountains are patient. It does not mind that you are tired. It does not judge that you need rest. It simply offers itself as a place of refuge, of peace, of restoration. This mountain is your destination tonight, but it is also right here, right now. You are already there, in the sense that matters. You are already held by mountain calm. Your breathing is deep now, steady, like the breathing of the earth itself. In and out. Rise and fall. Like tides, like seasons, like the eternal rhythm of nature. You are part of this rhythm. You have always been part of it. Tonight, you are simply remembering, settling back into the pattern that has held life since the beginning. As we move into the story proper, into the exploration of mountains and minds, remember that you can let go anytime. You do not need to hear it all. In fact, the moment you no longer hear these words, the moment you slip into sleep, that is success. That is the goal. This is not a story with a plot you need to follow to the end. This is a path into sleep, and you can step off that path into dreams whenever you are ready. I will be here, speaking softly, keeping watch, holding space for your rest. You are safe. You are held. You can let go completely. The mountain is waiting. Your breath is steady. Your body is heavy and relaxed. Your mind is beginning to drift like fog through mountain valleys. It is time to begin. Let us begin a gentle journey together, one that climbs slowly through the remarkable relationship between mountains and the human mind. Close your eyes if you wish, and let these words carry you upward, into the quiet spaces where earth meets sky. Mountains have always called to us. But have you ever wondered why? The answer begins not in the peaks themselves, but in the ancient pathways of your brain, pathways carved over millions of years of human evolution. When our earliest ancestors looked toward the mountains, they saw something essential. High places meant safety from floods. They meant vantage points to spot danger. They meant fresh water flowing down in streams. And so, over countless generations, the human brain developed a deep, almost unconscious response to mountain landscapes. The sight of peaks and ridges activates the same neural pathways associated with safety and shelter, triggering a release of serotonin, that gentle chemical messenger that helps regulate your mood and brings a sense of calm. This is why, even now, when you see a mountain photograph or stand before a real peak, something in you relaxes. Your amygdala, that ancient alarm system in your brain, quiets down. It recognizes the pattern, high ground equals security. But there is more to this story, much more. Let us climb higher together. As you ascend a mountain, something remarkable happens to your brain chemistry. The air grows thinner, and with each breath, you take in less oxygen. This might sound concerning, but your brain is extraordinarily adaptive. Within just a few hours at elevation, your body begins producing more red blood cells, instructed by your kidneys to carry oxygen more efficiently. Your breathing rate increases, not in panic, but in a steady rhythm that becomes almost meditative. Many people report feeling a sense of euphoria in the mountains, and there is science behind this. The slight oxygen reduction triggers your brain to release endorphins, those natural painkillers and mood elevators that create what mountaineers call altitude high. It is your brain's way of protecting you, of helping you feel good even as you face the challenge of thinner air. The visual experience of mountains also does something profound to your mind. The human brain has neurons specifically designed to respond to horizontal lines. These are the foundations of landscapes, the stable horizons that helped our ancestors navigate. But mountains disrupt this with dramatic vertical lines, with peaks that thrust upward, breaking the expected pattern. This visual disruption activates your brain's attention networks, pulling you into the present moment. It is one reason why mountain landscapes are so captivating, why your eyes keep returning to that distant summit. Let us pause here for a moment, in this imaginary ascent, and consider the colors around us. Mountains present a particular palette to your eyes. The blues of distant ranges, fading into lighter shades with distance. The grays and whites of rock and snow. The deep greens of alpine forests. These colors are not random in their effect on you. Blue, especially, triggers the release of dopamine in your brain. It is associated with openness, with possibility, with the endless sky. Studies have shown that people viewing blue landscapes experience decreased activity in the prefrontal cortex, the part of your brain responsible for overthinking and worry. Your mind literally quiets down. The color green of mountain forests has its own magic. Your retina has more receptors for green than any other color, an evolutionary gift from our tree-dwelling ancestors. When you see the green of mountain vegetation, your parasympathetic nervous system, your rest and digest mode, gently activates. Your heart rate slows. Your breathing deepens. Your body knows it is safe. Now, let us think about the sounds of mountains, for they too shape your neural landscape. Silence. True silence. In the mountains, far from human noise, you can experience sound levels below 30 decibels. This is quieter than a whisper. And when your auditory cortex encounters this silence, something beautiful happens. It stops straining to process information. It rests. This allows your default mode network, the parts of your brain active during rest and introspection, to become more prominent. You begin to think more creatively. You reflect more deeply. The silence creates space in your mind. But mountain silence is never complete silence. There is wind moving through peaks, creating what acoustic researchers call pink noise, a sound frequency that actually promotes deeper sleep and improved focus. There is the distant sound of water, streams fed by snowmelt, which creates patterns of sound that your brain finds inherently soothing. The rhythm of moving water synchronizes with alpha waves in your brain, those patterns associated with relaxed alertness. As we climb higher in our story, the relationship between mountains and memory emerges. Your hippocampus, the seahorse-shaped structure deep in your brain responsible for forming memories, shows increased activity when you experience novel landscapes. Mountains, with their ever-changing play of light and shadow, their unique rock formations, their surprising vistas around each turn, provide constant novelty. This is why mountain experiences form such vivid memories. Your brain is drinking in the newness, encoding it deeply. But here is something even more fascinating. Studies using functional MRI scans have shown that when people view mountain landscapes, their brains activate the same regions involved in processing rewards. The nucleus accumbens lights up, the same area that responds to music you love, to delicious food, to seeing someone you care about. Your brain literally treats mountain views as a reward, releasing dopamine and creating a sense of pleasure and anticipation. This might explain why mountaineers speak of mountains as addictive, why the call to return is so strong. Your brain has learned that mountains equal reward, and it wants that feeling again. Let us consider now the way mountains affect your sense of time. In the mountains, time seems to slow down. This is not merely a subjective impression. The reduced oxygen, the physical exertion, the need to focus on each step, all of these engage your brain in a way that expands your perception of time. When your brain is processing more information, when it is more engaged with the present moment, time stretches. Minutes feel longer. Hours become rich with experience. This effect is amplified by the scale of mountains. When you stand before a peak that rises thousands of feet above you, your brain struggles to process the size. The visual cortex sends signals that something vast is before you, but your sense of distance, calibrated for everyday objects and spaces, cannot quite grasp it. This creates what neuroscientists call cognitive disfluency, a slight confusion that actually increases your engagement and attention. You become more present, more aware, more absorbed in the moment. The physical act of climbing also changes your brain in measurable ways. When you walk uphill, your cardiovascular system works harder, sending more oxygen-rich blood to your brain. This increased blood flow particularly benefits your prefrontal cortex, improving executive function, decision-making, and emotional regulation. Even a moderate uphill walk increases the production of brain-derived neurotrophic factor, or BDNF, a protein that acts like fertilizer for your brain cells, promoting the growth of new neurons and the strengthening of neural connections. Regular mountain hiking has been shown to increase the size of the hippocampus, improving memory function. It reduces inflammation throughout the body and brain. It promotes neuroplasticity, your brain's ability to form new pathways and adapt. In essence, mountains help your brain grow and stay healthy. Now, let us explore the fascinating relationship between mountains and your stress response. When you encounter a challenge, your hypothalamic pituitary adrenal axis activates, releasing cortisol, your primary stress hormone. In modern life, this system often stays activated, leading to chronic stress. But mountains offer something different. They present real, physical challenges, but within a natural environment that simultaneously soothes your nervous system. This creates what psychologists call positive stress or eustress. Your body releases cortisol to help you climb, to help you navigate rocky terrain, but the natural environment prevents this from tipping into distress. The green colors, the fresh air, the expansive views, all of these continuously signal safety to your amygdala. You experience the invigoration of challenge without the harm of chronic stress. After a mountain experience, your cortisol levels drop significantly. Studies have measured this, showing that just 3 days in mountain environments can reduce cortisol to levels associated with deep relaxation. Your body recalibrates, your stress response resets, and you return to balance. The air itself in mountains has properties that affect your brain. At higher elevations, the air contains more negative ions, molecules that carry an extra electron. When you breathe these in, they increase the flow of oxygen to your brain. They affect serotonin production, potentially elevating mood and increasing alertness. They neutralize free radicals, reducing oxidative stress on your neurons. Mountain air is also cleaner, containing fewer particulates and pollutants. Urban air pollution has been linked to reduced cognitive function and increased risk of neurodegenerative diseases. When your brain gets a break from these pollutants, when it receives clean mountain air, it functions more efficiently. Neural inflammation decreases. Cognitive performance improves. The temperature of mountains also plays a role in how they affect your mind. Mountains are generally cooler than valleys and lowlands. This coolness triggers thermoreceptors in your skin, sending signals to your hypothalamus. In response, your brain increases production of norepinephrine, a neurotransmitter that enhances attention and focus. This is one reason why cool mountain mornings feel so clarifying, why your thoughts seem sharper in that crisp air. At night, mountains cool even further. This temperature drop aligns with your body's natural circadian rhythm, which expects temperature to fall as sleep approaches. The coolness helps trigger the release of melatonin, your sleep hormone, from the pineal gland. Combined with the absence of light pollution in mountain areas, allowing true darkness, this creates ideal conditions for deep, restorative sleep. Let us turn now to the way mountains affect your spatial awareness and navigation. When you navigate mountain terrain, your brain's spatial mapping systems work overtime. The entorhinal cortex and hippocampus create cognitive maps of your surroundings, building neural representations of the landscape. This is ancient brain function, the same systems that helped our ancestors remember where food sources were, where danger lurked. Studies have shown that people who regularly navigate complex terrain have larger hippocampi and better spatial memory overall. The brain plasticity triggered by mountain navigation transfers to other cognitive domains. Your memory improves. Your problem-solving skills sharpen. The mental work of navigation strengthens your brain. Mountains also recalibrate your sense of scale and perspective in ways that affect your emotional state. When you stand before a massive peak, your brain's ability to make social comparisons, to worry about your status or how you measure up to others, temporarily diminishes. The parietal lobe, involved in distinguishing self from environment, shows decreased activity. You experience what psychologists call small self, a feeling of being part of something larger, a diminishment of ego that paradoxically feels freeing rather than threatening. This sense of awe, this feeling of being small before something vast, triggers activity in the vagus nerve, your body's primary relaxation pathway. Your heart rate variability increases, a marker of resilience and emotional regulation. Stress hormones decrease. Cytokines, markers of inflammation, drop. The experience of awe is physiologically healing. Consider now how mountains affect your breathing, and through breathing, your mind. The exertion of climbing naturally deepens your breath. You begin to breathe from your diaphragm, taking fuller, slower breaths. This type of breathing activates your parasympathetic nervous system, your rest and digest mode. It increases the tone of your vagus nerve, that crucial pathway connecting brain and body. With each deep breath at elevation, you trigger the baroreceptors in your lungs and blood vessels. These sensors send calming signals to your brainstem, which in turn reduces activity in your amygdala, your fear center. The simple act of breathing deeply in mountain air becomes a form of neural regulation, a way of calming your entire nervous system. Mountains also influence your relationship with uncertainty and risk assessment. Mountain terrain is unpredictable. Weather changes rapidly. The path ahead is not always clear. This uncertainty keeps your anterior cingulate cortex engaged, the part of your brain that monitors conflict and adjusts behavior. Rather than the anxiety-provoking uncertainty of modern life, this is contained uncertainty, bounded by the physical reality of the mountain. Your brain learns to tolerate ambiguity in this context. Research suggests that exposure to this type of manageable uncertainty, where the stakes are real but you have agency in responding, builds resilience. Your brain becomes better at handling uncertainty in other areas of life. The mountain becomes a training ground for emotional regulation. The social aspects of mountain experiences also shape your neural responses. When people climb together, their brains show synchronized patterns. Facing challenges together, sharing the experience of summit views, creates what neuroscientists call neural coupling. Your brain waves begin to align with those of your companions. This synchronization deepens social bonds and triggers the release of oxytocin, the bonding hormone. Even climbing alone, you are part of a larger community of mountain lovers across time and space. This sense of connection, of being part of a tradition, activates your brain's social cognition networks. You feel less isolated, more connected to humanity's long relationship with high places. Let us contemplate the way mountains affect your sense of accomplishment and self-efficacy. When you set a goal to reach a summit and achieve it, your brain's reward system floods with dopamine. But it is more than just a chemical rush. The ventromedial prefrontal cortex, involved in self-reflection and evaluation, shows increased activity. You update your self-concept. You see yourself as someone who can overcome challenges, who can persist through difficulty. This neural updating has lasting effects. Studies show that challenging outdoor experiences improve self-efficacy, your belief in your own capabilities, for months afterward. The mountain changes not just your body, but your fundamental sense of who you are and what you can do. The geological time scale of mountains also affects how your brain processes time and existence. When you touch rock that is millions of years old, when you see peaks that have stood for epochs, your brain struggles to comprehend such vast timescales. This cognitive stretch, this attempt to grasp deep time, activates your temporal lobe and prefrontal cortex in unique ways. It provides perspective on your own brief existence, a perspective that many find both humbling and comforting. This perspective shift has been linked to decreased rumination, that repetitive negative thinking that characterizes anxiety and depression. When you zoom out to geological timescales, your immediate worries naturally shrink. Your prefrontal cortex, freed from the tight focus on immediate concerns, can engage in broader, more creative thinking. Mountains in different seasons affect your brain differently. In winter, snow-covered mountains reflect light intensely, providing your brain with bright light exposure even in the shorter days. This light stimulates your suprachiasmatic nucleus, your brain's master clock, helping regulate circadian rhythms. It suppresses melatonin during the day, making you more alert, while allowing it to rise naturally at night. Spring in the mountains brings the smell of new growth, sense that your olfactory bulb processes and sends directly to your limbic system, your emotional brain, without filtering through conscious thought first. The smell of pine, of fresh earth, of wildflowers, each triggers distinct emotional responses and memories, connecting you to past experiences and creating new neural associations. Summer mountains offer extended daylight, allowing your brain more time for serotonin production. Fall brings the visual spectacle of changing colors, yellows and oranges and reds that activate your brain's visual processing areas in particularly intense ways, creating vivid memories and strong emotional responses. The biodiversity of mountains also plays a role in their neural effects. Mountains are biodiversity hotspots, containing numerous species in relatively small areas. When your brain encounters this diversity, whether consciously recognized or not, it responds with interest and engagement. The variety of bird calls, of plant species, of insects and animals, all provide rich sensory input that keeps your brain alert and engaged without overwhelming it. Researchers have found that exposure to biodiverse environments improves cognitive function more than exposure to less diverse settings. Your brain evolved in complex natural environments, and it still thrives on that complexity. Let us consider the spiritual and contemplative dimensions that mountains evoke in the brain. Throughout human history, mountains have been considered sacred spaces. This is not merely cultural, but has neural correlates. When people engage in contemplative practices in mountain settings, brain imaging shows decreased activity in the parietal lobe, particularly the area that helps you distinguish self from environment. Simultaneously, the frontal lobes involved in focused attention show increased activity. This pattern, reduced sense of separate self combined with heightened awareness, is associated with transcendent experiences. Mountains naturally facilitate these states. The combination of physical exertion, thin air, vast views, and the cultural framing of mountains as special places all contribute to what might be called spiritual experiences, but which have clear neural signatures. The challenges mountains present also activate your brain's problem-solving networks in beneficial ways. When you encounter a difficult passage, your dorsolateral prefrontal cortex engages, planning and strategizing. Your parietal cortex processes spatial information. Your motor cortex prepares and executes movements. Your cerebellum coordinates everything, ensuring smooth, balanced motion. This full brain engagement is profoundly healthy. It is the kind of integrated neural activity that promotes connectivity between brain regions. Modern life often engages only limited brain areas, keeping us in our prefrontal cortex, in abstract thought and planning. Mountains demand whole brain, whole body engagement. This integration is restorative. Mountains also affect your relationship with fear and your ability to manage it. Exposure to heights naturally triggers some fear response. Your amygdala activates when you peer over a cliff edge. But in a mountain context, where you have control and agency, where you can choose your level of exposure, this fear becomes manageable. Your prefrontal cortex learns to regulate the amygdala's alarm signals. This neural practice in fear regulation transfers to other situations. Research on adventure experiences shows they improve emotional regulation generally. Your brain gets better at assessing risk accurately, at distinguishing real danger from perceived threat, at staying calm in the face of challenge. The light quality in mountains has distinct effects on your visual system and beyond. At altitude, there is less atmosphere to scatter light. Colors appear more saturated. Contrasts are sharper. This visual intensity engages your occipital lobe more fully, creating richer visual experiences that encode more strongly into memory. It is why mountain sunsets seem so spectacular, why the quality of light is so often remarked upon. This intense visual stimulation also affects mood. Your retina contains photoreceptors that don't contribute to vision but instead send signals directly to mood-regulating centers in your brain. Bright mountain light stimulates these receptors, influencing serotonin production and helping regulate your sleep-wake cycle. The rhythms of mountain weather create natural opportunities for mindfulness. Clouds build and dissipate. Wind rises and falls. Sun gives way to shadow and back again. These constant changes, observable yet beyond your control, provide an ideal focus for present moment awareness. Your attention anchors to the changing weather, and in doing so, pulls away from rumination about past or future. This externally focused attention gives your default mode network, the brain network active during self-referential thinking, a rest. The medial prefrontal cortex and posterior cingulate cortex, core hubs of this network, show decreased activity. This reduction is associated with decreased anxiety and depression symptoms. Mountains teach your brain about patience and process. A summit is reached through countless steps, each one small, none dramatic in itself. Your brain learns that progress is incremental, that large goals are achieved through persistent small actions. The anterior cingulate cortex and dorsolateral prefrontal cortex, areas involved in sustained attention and goal pursuit, strengthen with this repeated practice. This neural learning about patience and persistence manifests in other areas of life. People who regularly engage with mountain climbing show improved ability to delay gratification and maintain long-term goals. The descent from mountains offers its own neural gifts. After the achievement of a summit, the return journey allows your brain to shift into a different mode. The goal pressure releases. You can observe more freely, notice details missed on the way up. Your parasympathetic nervous system becomes more active. It is a time of integration, when your brain processes the experience, forming memories, extracting meaning. The descent also requires different skills, engaging your cerebellum and motor cortex in unique ways as you navigate downward, controlling momentum, placing feet carefully on loose terrain. This variety of neural engagement throughout an entire mountain experience contributes to its restorative power. Finally, let us consider how the absence of mountains affects those who have known them. Once your brain has experienced mountains, it remembers. Simply looking at mountain photographs can partially reactivate the neural patterns associated with being there. Thinking about future mountain trips activates anticipation circuits, releasing dopamine even before you go. Some researchers speak of nature deficit disorder, the effects of insufficient contact with natural environments. For those who love mountains, the absence creates a kind of neural hunger, a longing that is not merely emotional but physiological. Your brain remembers the specific neural state that mountains induce, the particular pattern of calm alertness, of present moment awareness, of integrated whole body-mind experience. And it seeks that state again. This is why mountains call us back. It is not merely beauty, though they are beautiful. It is not merely challenge, though they are challenging. It is that mountains create a brain state, a way of being, that feels profoundly right to us. They activate ancient neural pathways while calming modern anxieties. They engage our whole being in integrated ways that our everyday lives rarely do. Mountains remind your brain what it evolved for: movement through complex terrain, attention to immediate surroundings, cooperation with companions, problem-solving in real time, awe at the vastness of the world. They provide experiences that your neural architecture is designed to handle and thrive upon. And so we return, again and again, to high places. We return because something in us recognizes those peaks as home, as the landscape our minds are shaped to inhabit. Not exclusively, for we are adaptable creatures who can flourish in many environments. But mountains offer something essential, something our brains need and crave and remember. As you drift towards sleep now, imagine yourself on a mountain path. Feel the cool air on your skin. See the path winding upward through the trees. Hear the wind moving through the peaks above. Let your brain settle into that ancient rhythm, that peaceful alertness that mountains evoke. Your neural pathways are quieting now. Your amygdala is calm, recognizing the safety of high ground. Your visual cortex rests, no longer processing information. Your prefrontal cortex releases its grip on planning and worry. Your default mode network shifts into the patterns associated with sleep. The mountain in your mind is always there, always waiting. You can return to it whenever you need that particular peace, that specific quality of calm that only high places bring. Your brain knows the way. It has walked these paths for millennia. Rest now. Let the mountain hold you in its ancient stone arms. Let your breath slow to match the wind through distant peaks. Let your thoughts drift like clouds across a summit. The mountain asks nothing of you now except that you rest, that you let go, that you sleep. And in your sleeping, your brain will do its quiet work, consolidating memories, strengthening neural connections, preparing you for tomorrow. The mountain has given you its gifts: calm, perspective, strength, peace. Now sleep. Sleep deep and dreamless as the ancient stone. Sleep sound as someone who has climbed high and can rest well. Sleep knowing that the mountains will be there when you wake, calling you back, offering their particular wisdom to your waiting brain. Sleep now. The mountains are patient. They will wait. Sleep. But our journey is not yet complete. There are deeper layers to explore, more connections between mountain and mind waiting to be understood. Let us continue climbing together, higher still, into the quieter realms where earth and consciousness meet. Consider how mountains shape your relationship with gravity itself. Every moment on a mountain, your vestibular system works to keep you balanced. Deep within your inner ear, tiny hair cells sense the pull of gravity, the tilt of your head, the movement of your body through space. This constant sensory input travels to your cerebellum and brainstem, creating a heightened proprioceptive awareness. You become more conscious of your body and space, more grounded in physical reality. This enhanced body awareness has profound effects on anxiety. When you are firmly rooted in physical sensation, when your attention is held by the needs of balance and movement, your mind has less capacity for worry. The insula, the brain region that integrates body sensations with emotional awareness, shows increased activity. You become more embodied, less lost in abstract thought. The simple act of walking uphill changes the neurochemistry of your gut, and through the gut-brain axis, your mind. Physical activity stimulates peristalsis, the movement of your digestive system. This movement, combined with deep breathing, massages your vagus nerve, that wandering pathway connecting brain and body. Your gut produces more serotonin when you move, and 90% of your body's serotonin is made in your digestive tract, not your brain. This gut-derived serotonin influences mood, even though it cannot cross the blood-brain barrier directly. It signals through the vagus nerve, informing your brain that all is well, that your body is functioning smoothly. Mountains also affect your relationship with hunger and satiation in interesting ways. At altitude, the hormone leptin, which signals fullness, increases in your bloodstream. Your appetite often decreases. This is your body adapting to the metabolic demands of elevation. But there is a mental component too. The prefrontal cortex regions involved in impulse control and decision-making are engaged by the challenges of mountain terrain. This engagement seems to strengthen self-regulation generally, including around food. Mountaineers often report that food tastes different at altitude, more intense somehow. This may be partly due to changes in taste perception from lower oxygen, but also because when you are truly physically hungry, when you have earned your meal through exertion, your brain's reward response to food intensifies. The simple becomes sublime. Let us think about how mountains influence your circadian rhythms beyond what we have already explored. The natural light-dark cycle in mountains, uninterrupted by artificial lighting, allows your suprachiasmatic nucleus to synchronize with the solar day. Within a few days in the mountains, your cortisol awakening response normalizes. You wake naturally at dawn, cortisol rising to energize you. You grow sleepy as darkness falls, melatonin increasing without the suppression caused by screens and artificial light. This alignment of internal and external rhythms affects every system in your body. Your immune function optimizes. Your metabolism regulates. Your mood stabilizes. The master clock in your hypothalamus conducts the symphony of your bodily rhythms, and mountains provide the natural timing cues it evolved to follow. Mountains teach your brain about the relationship between effort and reward in visceral ways. Each step upward requires work. Your muscles burn. Your lungs work harder. Your heart pumps faster. The anterior cingulate cortex monitors this effort, this cost. And then you round a corner and a view opens before you, vast and breathtaking. The orbitofrontal cortex processes this reward. Your brain learns that effort leads to reward, that difficulty precedes beauty. This neural learning is powerful. It strengthens the connections between your ventral striatum, which processes rewards, and your prefrontal regions involved in planning and persistence. You become better at tolerating short-term discomfort for long-term gain. The mountain is a teacher, and the lesson is written in neural connections. The particular quality of mountain ecosystems affects your immune system through your brain. Forests and mountains release phytoncides, airborne chemicals that trees produce to protect themselves from insects and decay. When you breathe these compounds, they do not simply stay in your lungs. They enter your bloodstream. They influence your immune system, increasing the activity of natural killer cells that fight tumors and infections. But the pathway also runs through your brain. Your olfactory system detects these forest compounds and sends signals to your limbic system. This triggers a parasympathetic response, reducing stress hormones that suppress immune function. The forest-covered mountain becomes medicine, delivered through both chemistry and neurology. Consider how mountains affect your relationship with solitude and your sense of self. In mountain solitude, without the constant social stimuli of modern life, your brain's social processing networks rest. The temporoparietal junction and medial prefrontal cortex, areas constantly active when you navigate social interactions, can quiet. This is not loneliness, which activates threat responses. This is chosen solitude, which allows your brain to consolidate your sense of identity separate from social roles and expectations. Research shows that people who spend time alone in nature report stronger sense of self and greater clarity about their values and desires. The mountain provides space for your brain to ask, "Who am I, apart from my relationships and roles?" The answers that emerge are often profound. Mountains influence your relationship with technology and your brain's need for digital detox. Most mountain areas have limited or no cell service. This forced disconnection allows your brain to shift out of the constant partial attention that characterizes much modern life. The prefrontal cortex, exhausted from constant task switching between notifications and demands, can finally rest and recover. Studies of people on wilderness trips show that after 3 days without technology, creative problem-solving abilities increase by 50%. The brain needs time to defragment, to process experiences without constant new inputs. Mountains provide this time. Your default mode network can engage in deeper processing, making unexpected connections, generating insights that the constantly interrupted mind cannot produce. The geological features of mountains tell stories that your brain finds inherently compelling. Layered sedimentary rock reveals millions of years of history. Folded and faulted stone shows the immense forces that built these peaks. Your brain loves stories, and mountains are stories written in stone. The fusiform gyrus and other areas involved in visual processing and pattern recognition engage intensely with these geological narratives. Understanding, even vaguely, that you are looking at ancient seabeds now lifted miles into the air, that these rocks have been on a journey as epic as any human tale, activates your sense of wonder. And wonder, researchers find, is associated with decreased inflammation, improved immune function, and greater life satisfaction. The mountain story becomes part of your story. Let us explore how mountains affect your relationship with weather and your sense of agency. In the mountains, weather is immediate and consequential. You cannot ignore it. You must respond to it. This requirement keeps your anterior cingulate cortex, involved in monitoring and responding to changing conditions, actively engaged. You are neither passive nor in control. You are responsive. This balanced state, neither helpless nor omnipotent, is psychologically healthy. It builds what researchers call adaptive control, the ability to adjust your approach based on circumstances while maintaining your goals. Your brain practices flexibility while maintaining purpose. Watching storm systems move through mountains provides a metaphor that your brain processes literally and figuratively. Clouds come and go. Rain falls and stops. The storm passes. Your emotional brain, watching this, learns that difficult states are temporary, that clarity returns. This is not just philosophical wisdom, it is neural learning encoded through repeated observation. Mountains affect your relationship with risk in your brain's probability assessment systems. Objective hazards exist in mountains: loose rock, weather changes, difficult terrain. but these risks are accessible. Your dorsolateral prefrontal cortex, involved in logical reasoning, can evaluate them. This is different from the vague, unspecific anxiety that characterizes much modern worry. When you successfully assess and navigate real risks, your brain's confidence in its risk assessment abilities grows. The anterior insula, which processes uncertainty and risk, becomes better calibrated. You learn to distinguish between realistic caution and unnecessary fear. This skill transfers beyond the mountain. The alpine environment, above the tree line, creates unique visual experiences that affect your brain distinctly. In the alpine zone, the landscape becomes spare. Rock, snow, sky. The reduced visual complexity creates a different kind of engagement than the rich biodiversity of forests. Your visual cortex processes less information, but more carefully. There is space for sustained attention on single elements, the pattern of lichen on rock, the way light plays on snow, the shape of a distant peak. This sustained, focused attention is increasingly rare in modern life. It allows your dorsal attention network to strengthen. You become better at voluntary, sustained focus. The sparse beauty of alpine landscapes trains attention. Mountains influence your relationship with mortality and your brain's processing of existential questions. Mountains are dangerous. This is simply true. And in facing this truth, in accepting that real consequences exist for poor decisions, your brain engages with mortality in a direct way. The ventromedial prefrontal cortex, involved in processing the meaning and value of experiences, shows increased activity when people contemplate mortality in nature settings. Rather than the anxious denial that characterizes much of how modern culture handles death, mountains allow a calm acceptance. You are small. The mountain is large and ancient. Someday you will not be here, but the mountain will remain. And somehow, this perspective is not depressing but freeing. Your brain's terror management systems relax. You can be present in life more fully when you have accepted its limits. Consider how the flora and fauna of mountains affect your brain through observation and interaction. Watching a marmot sun itself on a rock, you engage your mirror neuron system. You feel, subtly, what the marmot seems to feel: warmth, contentment, simple being. Observing birds navigate air currents with effortless skill activates your motor areas, your brain simulating the movements it watches. This observation of animal life connects you to the broader community of living things. The superior temporal sulcus, involved in biological motion perception, and the precuneus, involved in consciousness and self-reflection, activate together. You are reminded that you are an animal too, part of nature, not separate from it. This recognition seems to reduce activity in brain networks associated with psychological distress. Mountains affect your understanding of power and your brain's relationship with forces beyond your control. An avalanche rumbling down a distant slope, the crack of thunder echoing between peaks, the wind that can literally knock you down, all of these demonstrate power that dwarfs human strength. Your brain's threat assessment systems note this, but in a context where you can usually avoid or escape the danger. This experience of power safely observed teaches humility without helplessness. The ventromedial prefrontal cortex integrates this learning: respect power, but do not freeze in fear. This neural lesson applies broadly. You can face powerful forces, natural or social, with appropriate caution but not paralysis. The minerals and trace elements in mountain water affect your brain chemistry subtly. Mountain streams carry dissolved minerals from the rock they flow over. Magnesium, calcium, trace lithium in some regions. While the amounts are small, regular consumption may influence neural function. Magnesium is crucial for neurotransmitter regulation. Calcium is essential for neural signaling. Natural lithium, even in tiny amounts, has been associated with neuroprotective effects and mood stabilization in population studies. The act of drinking directly from a mountain stream, when safe to do so, also carries psychological weight. Your brain registers the immediacy, the connection to the source of life. This is not mediated water, processed and transported. This is water in its wild state, and drinking it feels like participating directly in natural cycles. Mountains influence your breath patterns in ways beyond the mechanical response to altitude. The expansiveness of mountain views seems to inspire deeper breathing. People unconsciously inhale more deeply when they look out over vast landscapes. This is partly a response to awe, that sense of vastness that makes you want to take it all in. Deep inhalations stimulate stretch receptors in your lungs, which send calming signals through your vagus nerve to your brainstem. This breath-awe connection creates a positive feedback loop. The view takes your breath away. You breathe deeply to take it in. The deep breath calms your nervous system. The calmness allows you to be even more present to the experience. Your brain learns to associate vastness with calm, openness with safety. The different types of rock in mountains affect your sensory experience and through it, your neural state. Granite feels different under your hand than limestone. Slate breaks into flat sheets. Basalt forms geometric columns. Your somatosensory cortex processes these different textures richly. The variations in touch, in visual pattern, in the effort required to move over different surfaces, all provide your brain with rich, varied input. This sensory richness is cognitively stimulating. Your parietal lobe integrates all this touch and spatial information. Your premotor cortex plans movements based on the terrain. Varied sensory input keeps your brain engaged and alert without overwhelming it. The mountain's diversity of surface and structure becomes a form of gentle stimulation that maintains optimal arousal. Let us explore how the pace of change in mountains affects your brain's temporal processing. Mountains change slowly. The succession from bare rock to lichen to moss to alpine flowers to shrubs to trees unfolds over decades or centuries. Even the weather, while it can change dramatically, follows patterns that repeat seasonally. This slower pace of change provides your brain with a temporal framework very different from the rapid-fire changes of modern life. Your hippocampus, which encodes sequences and events, seems to benefit from this slower pace. It has time to fully process each experience before the next arrives. The result is richer memory formation and a sense of time that feels more spacious, less rushed. Mountains influence your brain's processing of personal narratives and life stories. Many people use mountain journeys as metaphors for life challenges. The climb represents struggle. The summit represents achievement. The descent represents return and integration. Your brain does not just understand these metaphors intellectually. The medial prefrontal cortex, involved in self-referential processing and narrative construction, actually uses physical mountain experiences to structure understanding of psychological journeys. Neuroscientists find that we understand abstract concepts through embodied metaphors. Up is good, down is bad. Climbing is progress. These are not just linguistic conventions. They are how your brain actually represents these ideas, grounded in physical experience. Mountains provide the literal experiences that your brain uses to structure understanding of life itself. The practice of making camp in mountains affects your brain's relationship with shelter and safety. When you set up a tent on a mountain, you create a small zone of safety within wildness. This act engages ancient brain systems related to territory and shelter. The posterior hypothalamus, involved in motivated behaviors including creating safe spaces, activates. Your amygdala, initially alert to exposure, calms as shelter is established. This process of creating safety, rather than finding it ready-made, teaches your brain that you have agency in making yourself secure. This sense of agency, neuroscientists find, is fundamental to mental health and resilience. You are not passively dependent on existing structures for safety. You can create safety yourself. Mountains affect your relationship with light in profound ways throughout the day. Dawn in the mountains often means watching alpenglow, that pink-orange light that illuminates peaks before the sun rises. This particular quality of light, with its warm tones and gradual intensification, provides an ideal circadian signal. Your retinal ganglion cells, particularly those containing melanopsin that regulate your body clock, respond optimally to this warm, gradually brightening light. Midday mountain light, intense and bright, provides the light exposure that suppresses melatonin and promotes alertness. Evening alpenglow, as the sun sets, provides the shift to warmer, dimmer light that signals approaching night. Your circadian system receives clear, appropriately timed signals throughout the day, something artificial lighting rarely provides correctly. The experience of being weathered, of facing wind and cold and effort, affects your brain's resilience systems. When you are uncomfortable on a mountain, when you are cold or tired or pushing through difficulty, your brain faces a choice: give up or persist. Each time you choose persistence and succeed, you strengthen neural pathways involved in grit and determination. The anterior cingulate cortex and dorsolateral prefrontal cortex, regions involved in sustained effort, show increased connectivity with repeated practice. This is controllable adversity, hardship with an endpoint, difficulty you chose. Your brain learns from this that discomfort is not emergency, that you can function and even thrive in challenging conditions. This neural learning builds psychological resilience that extends far beyond the mountain. Mountains influence your relationship with sound and silence in layered ways. The silence of mountains is not absence but presence. Wind moves through different surfaces, creating varied sounds: the whisper through grass, the rustle through leaves, the whistle around rock. Your auditory cortex processes this as complex, evolving soundscape. It is stimulating enough to prevent the anxiety some people feel in complete silence, but calm enough to allow rest. The distance sounds carry in mountain air, the way a voice echoes off cliff faces, the sudden appearance of sound as wind shifts, all of these affect your spatial hearing. Your superior olivary complex, which localizes sound, stays gently engaged. You maintain spatial awareness through sound, a form of environmental monitoring that keeps you safely alert without stress. The act of summit reaches affects your brain's achievement processing systems differently than other accomplishments. A mountain summit is unambiguous. You are either there or you are not. There is no faking it, no partial credit. Your brain's goal satisfaction systems respond to this clarity. The ventral striatum releases dopamine in response to clear goal achievement. But mountains also teach that the summit is not the end. You must ascend safely. The goal is complete only when you return. This complete arc, ascent and descent, effort and return, affects how your brain structures goals. The prefrontal cortex learns to include the full cycle in its planning. Success is not just reaching the objective, it is completing the entire process safely. This more complete understanding of achievement leads to better long-term planning and satisfaction. Mountain stars affect your brain in ways different from any other night sky experience. At altitude, with no light pollution, the stars are overwhelming in their number and brightness. The Milky Way is clearly visible, a river of light across the sky. Your visual cortex, evolved to process earthbound scenes, struggles with the vastness. You experience cognitive disfluency again, that productive confusion that increases engagement. Looking at stars also activates your brain systems for processing infinity and vast scales. The parietal cortex, involved in numerical and spatial reasoning, engages with the attempt to comprehend cosmic distances. This engagement with vastness has been linked to decreased self-focus and increased feelings of connection to something larger than oneself. The different types of mountain environments, from gentle hills to technical peaks, each affect your brain distinctly. Rolling foothills provide gentle elevation gain, enough to benefit cardiovascular function and brain blood flow without triggering stress responses. Your brain can wander, engage in creative thought, while your body moves steadily. The default mode network stays active, processing and integrating thoughts. Technical peaks require focused attention. Every handhold, every foot placement matters. Your dorsal attention network fully engages. The experience is flow-like, absorbing. Different neural needs are met by different mountain challenges. This variety means mountains can provide what your brain needs in different moments. Let us consider how mountain photography and art making affect your brain differently in city than elsewhere. When you photograph or sketch a mountain scene while present in it, your brain engages differently than when you photograph elsewhere. You are not just capturing an image, you are attempting to record an experience that includes thin air, vast scale, and embodied presence. The effort to translate this into 2 dimensions requires your brain to analyze the scene more deeply. The posterior parietal cortex, involved in spatial processing, and the fusiform gyrus, involved in visual analysis, show increased activity. You are not just seeing, you are studying, attempting to understand how to represent 3-dimensional space, atmospheric effects, and emotional quality in a photograph or sketch. This deep analysis enriches your memory and understanding of the place. Mountains affect your relationship with your own strength and limitations. As you climb, you feel your muscles fatigue. You notice your breath becoming labored. You experience your physical limits directly. The insula, which creates your conscious sense of your body's internal state, sends clear signals to your awareness. You are not abstractly tired, you are specifically, physically tired in these muscles from this exact effort. This direct knowledge of your limits, and your ability to push them just a little further, builds accurate self-knowledge. Your brain updates its models of your capabilities based on real data, not imagination or fear. You become neither overconfident nor underconfident, but accurately aware of what you can do. The ecological zones as you ascend a mountain provide your brain with clear environmental transitions. You pass from deciduous forest to coniferous forest to alpine meadow to bare rock. Each zone has distinct sights, sounds, smells, temperature. Your brain processes these transitions as clear shifts, creating what memory researchers call event boundaries. Your episodic memory system uses these boundaries to structure and organize memories. The result is that mountain experiences encode as clear narratives with distinct chapters. You remember not just the summit but the journey through zones, each phase with its own character. This structured encoding makes mountain memories particularly vivid and lasting. Mountains influence your relationship with effort through the simple physics of carrying weight upward. Every item in your pack must be carried up. This makes you conscious of weight in a direct way. You choose carefully what is necessary. Your brain engages in cost-benefit analysis that is immediate and physical. The dorsolateral prefrontal cortex, involved in planning and decision-making, must balance desire for comfort with the reality of carrying weight upward. This practice in making trade-offs, in feeling the direct consequences of choices, strengthens decision-making abilities. The feedback is immediate and physical. Your brain learns from this direct coupling of choice and consequence in ways that transfer to other decision domains. As you rest now, imagine you are camped on a mountain slope. Your tent is secure. The stars are emerging overhead. The air is cool and clean. You can hear a distant stream, the wind and the trees lower on the mountain. Your body is tired in the good way that comes from honest effort. Your mind is quiet, having released its usual concerns during the climb. This is the state mountain's gift to your brain: calm alertness, physical tiredness that invites sleep, mental quiet that comes from full engagement with the present moment. Your neural systems are balanced, your stress hormones are low, your body is ready for deep rest. Let yourself sink into this mountain sleep. Let the imagined ground beneath you be solid and supportive. Let the vast sky above you be a canopy of safety, of perspective, of peace. Your brain knows this place. It has always known it. High ground means safety. Thin air means clarity. Stone beneath means stability. Sleep now in this high place. Sleep as humans have slept in mountains for thousands of years, secure in the knowledge that you are in the right place, that you have done what you needed to do, that tomorrow will bring its own gifts, but now is for rest. Your neurons are settling into sleep patterns. Slow waves are beginning to roll through your cortex. Your consciousness is dimming like light fading from a peak at sunset. First the summit goes dark, then the upper slopes, then the middle reaches, until only the valley holds light, and then even that fades into peaceful darkness. Sleep in the mountain's arms. Sleep with stone below and stars above. Sleep with the wind as your lullaby and the dawn as your promise. The mountain holds you. The mountain knows you. The mountain welcomes you into rest. Sleep deeply now. Sleep long and restfully. Sleep the sleep of mountains, ancient and undisturbed. Sleep. Our journey together extends still further into the night. There are more mysteries to unfold, more connections between stone and synapse, between altitude and awareness. Let us continue, gently, exploring the most subtle ways that mountains shape the landscape of your mind. Consider how the age of mountains affects your psychological response to them. Young mountains, geologically speaking, are sharp and dramatic. The Himalayas, the Alps, the Rockies thrust upward with angular peaks and steep faces. Your visual cortex processes these sharp angles as exciting, even slightly threatening. The amygdala notes the dramatic forms. These mountains create a sense of awe tinged with healthy respect. Old mountains, worn smooth by time, like the Appalachians or the Scottish Highlands, present gentler profiles. Rounded summits, softer slopes. Your brain processes these as safer, more maternal somehow. Different mountains offer different neural experiences. Both have their gifts. Drama awakens. Gentleness soothes. Mountains influence your relationship with hydration and your brain's fluid balance. At altitude, you lose water more quickly through increased respiration and the dry air. Mild dehydration affects cognitive function, attention wanders, reaction time slows, mood dips. But the mountain teaches you to notice these signs, to respond by drinking. Your insula, monitoring your body's internal state, becomes better calibrated to thirst signals. This improved interoceptive awareness, this better connection between body signals and conscious attention, benefits you beyond the mountain. You become more attuned to your body's needs generally. The brain-body connection strengthens through this practice of noticing and responding to physical states. The practice of reading weather in mountains affects your pattern recognition abilities. You learn to read clouds. Lenticular clouds mean strong winds aloft. Cumulus building means possible afternoon storms. Mare's tails mean weather change approaching. Your fusiform gyrus and inferior temporal cortex, areas involved in pattern recognition, strengthen with this practice. You are training your brain to notice, remember, and apply patterns. This skill generalizes. People who develop strong pattern recognition in one domain show improvements in pattern recognition generally. Your brain becomes better at noticing meaningful patterns in data, in social situations, in any complex system. Mountains affect your proprioceptive map, your brain's representation of your body in space. Scrambling over uneven terrain, reaching for holds, balancing on narrow paths, all of these activities require constant proprioceptive feedback. Your posterior parietal cortex maintains and updates your body map based on this feedback. The representation becomes more detailed, more accurate, more integrated with your sense of self. People with strong proprioception show better emotional regulation and lower anxiety. The connection may be that when you are firmly grounded in physical sensation, when you know where your body is and what it is doing, your mind has a stable anchor. You are less likely to spiral into abstract worry when you are rooted in embodied awareness. Let us explore how the sound of your own footsteps on different surfaces affects your neural state. Crunching through snow produces a satisfying sound that your auditory cortex processes as progress. Scrambling over scree creates cascades of small stones, chaotic but controllable sound. Walking on solid rock produces confident, clear sounds. Each surface gives auditory feedback that your brain uses to assess the terrain and your movement through it. This audiomotor integration happens in the cerebellum and supplementary motor area. You are not just moving, you are hearing your movement, and the sound helps coordinate future movements. This multisensory integration is cognitively enriching. Your brain is processing information from multiple streams simultaneously, building a richer model of your environment. Mountains influence your sense of personal history and continuity of self. If you return to the same mountain over years, you experience it in different life stages. You remember who you were on previous climbs. The mountain becomes a constant against which you measure your own change. Your medial temporal lobe, particularly the hippocampus, encodes these layered memories, each visit overlaying the previous ones. This creates a sense of personal continuity even as you change. The mountain remains, you transform. This recognition of change against constancy is fundamental to self-understanding. Your brain needs both stability and change to maintain a coherent sense of identity across time. The practice of route finding in mountains enhances your executive function. You must constantly assess, is this the right way? Should I continue or turn back? What are my options? This ongoing decision-making engages your dorsolateral prefrontal cortex intensely. You are practicing flexible thinking, considering alternatives, making decisions with incomplete information. Studies show that people who regularly engage in complex navigation show better executive function across domains. The brain skills developed in route finding transfer to problem solving generally. Your cognitive flexibility increases. Your ability to shift strategies when the first approach does not work improves. Mountains affect your relationship with beauty in your brain's aesthetic processing. The beauty of mountains is not merely subjective. Brain imaging studies show that viewing scenes rated as beautiful activates the medial orbitofrontal cortex, an area involved in valuation and reward. Beautiful mountain scenes trigger similar neural responses to other universally appreciated stimuli like music and art. But mountain beauty has additional elements: scale, complexity, naturalness. Your parahippocampal place area, involved in processing scenes and spaces, shows strong responses to natural landscapes. The combination of reward activation and scene processing creates a rich aesthetic experience that is both emotional and cognitive. Consider how the effort of breathing at altitude affects your respiratory control and autonomic regulation. At elevation, you must consciously think about breathing more than usual. You take deeper breaths, you pace yourself, you notice the quality of each breath. This brings breathing, usually automatic, into conscious awareness. The ventrolateral medulla, your brain's breathing control center, receives more input from higher cortical areas. Our journey together extends still further into the night. There are more mysteries to unfold, more connections between stone and synapse, between altitude and awareness. Let us continue, gently, exploring the most subtle ways that mountains shape the landscape of your mind. Consider how the age of mountains affects your psychological response to them. Young mountains, geologically speaking, are sharp and dramatic. The Himalayas, the Alps, the Rockies thrust upward with angular peaks and steep faces. Your visual cortex processes these sharp angles as exciting, even slightly threatening. The amygdala notes the dramatic forms. These mountains create a sense of awe tinged with healthy respect. Old mountains, worn smooth by time, like the Appalachians or the Scottish Highlands, present gentler profiles. Rounded summits, softer slopes. Your brain processes these as safer, more maternal somehow. Different mountains offer different neural experiences. Both have their gifts. Drama awakens. Gentleness soothes. Mountains influence your relationship with hydration and your brain's fluid balance. At altitude, you lose water more quickly through increased respiration and the dry air. Mild dehydration affects cognitive function, attention wanders, reaction time slows, mood dips. But the mountain teaches you to notice these signs, to respond by drinking. Your insula, monitoring your body's internal state, becomes better calibrated to thirst signals. This improved interoceptive awareness, this better connection between body signals and conscious attention, benefits you beyond the mountain. You become more attuned to your body's needs generally. The brain-body connection strengthens through this practice of noticing and responding to physical states. The practice of reading weather in mountains affects your pattern recognition abilities. You learn to read clouds. Lenticular clouds mean strong winds aloft. Cumulus building means possible afternoon storms. Mare's tails mean weather change approaching. Your fusiform gyrus and inferior temporal cortex, areas involved in pattern recognition, strengthen with this practice. You are training your brain to notice, remember, and apply patterns. This skill generalizes. People who develop strong pattern recognition in one domain show improvements in pattern recognition generally. Your brain becomes better at noticing meaningful patterns in data, in social situations, in any complex system. Mountains affect your proprioceptive map, your brain's representation of your body in space. Scrambling over uneven terrain, reaching for holds, balancing on narrow paths, all of these activities require constant proprioceptive feedback. Your posterior parietal cortex maintains and updates your body map based on this feedback. The representation becomes more detailed, more accurate, more integrated with your sense of self. People with strong proprioception show better emotional regulation and lower anxiety. The connection may be that when you are firmly grounded in physical sensation, when you know where your body is and what it is doing, your mind has a stable anchor. You are less likely to spiral into abstract worry when you are rooted in embodied awareness. Let us explore how the sound of your own footsteps on different surfaces affects your neural state. Crunching through snow produces a satisfying sound that your auditory cortex processes as progress. Scrambling over scree creates cascades of small stones, chaotic but controllable sound. Walking on solid rock produces confident, clear sounds. Each surface gives auditory feedback that your brain uses to assess the terrain and your movement through it. This audiomotor integration happens in the cerebellum and supplementary motor area. You are not just moving, you are hearing your movement, and the sound helps coordinate future movements. This multisensory integration is cognitively enriching. Your brain is processing information from multiple streams simultaneously, building a richer model of your environment. Mountains influence your sense of personal history and continuity of self. If you return to the same mountain over years, you experience it in different life stages. You remember who you were on previous climbs. The mountain becomes a constant against which you measure your own change. Your medial temporal lobe, particularly the hippocampus, encodes these layered memories, each visit overlaying the previous ones. This creates a sense of personal continuity even as you change. The mountain remains, you transform. This recognition of change against constancy is fundamental to self-understanding. Your brain needs both stability and change to maintain a coherent sense of identity across time. The practice of route finding in mountains enhances your executive function. You must constantly assess, is this the right way? Should I continue or turn back? What are my options? This ongoing decision-making engages your dorsolateral prefrontal cortex intensely. You are practicing flexible thinking, considering alternatives, making decisions with incomplete information. Studies show that people who regularly engage in complex navigation show better executive function across domains. the brain skills developed in route finding transfer to problem solving generally. Your cognitive flexibility increases. Your ability to shift strategies when the first approach does not work improves. Mountains affect your relationship with beauty in your brain's aesthetic processing. The beauty of mountains is not merely subjective. Brain imaging studies show that viewing scenes rated as beautiful activates the medial orbitofrontal cortex, an area involved in valuation and reward. Beautiful mountain scenes trigger similar neural responses to other universally appreciated stimuli like music and art. But mountain beauty has additional elements: scale, complexity, naturalness. Your parahippocampal place area, involved in processing scenes and spaces, shows strong responses to natural landscapes. The combination of reward activation and scene processing creates a rich aesthetic experience that is both emotional and cognitive. Consider how the effort of breathing at altitude affects your respiratory control and autonomic regulation. At elevation, you must consciously think about breathing more than usual. You take deeper breaths, you pace yourself, you notice the quality of each breath. This brings breathing, usually automatic, into conscious awareness. The ventrolateral medulla, your brain's breathing control center, receives more input from higher cortical areas. Every foot of elevation you gain is measurable work against gravity. This makes effort quantifiable in a direct way. Your brain can track: I have climbed this many feet, I have this many more to go. The precision of the metric provides clear structure for effort. This quantifiability satisfies your brain's need for clear progress markers. The dorsal anterior cingulate cortex, involved in effort monitoring, has clear data to work with. You know exactly what you have accomplished and what remains. The practice of maintaining gear in mountain conditions affects your problem solving under constraint. If something breaks or malfunctions on a mountain, you must fix it with what you have. No running to a store for parts. Your brain must engage in creative problem solving with limited resources. The lateral prefrontal cortex, involved in reasoning and innovation, must find novel solutions. This constraint-based creativity is powerful. Some research suggests that creativity flourishes under constraints because the brain must think more flexibly, consider unusual approaches, repurpose available items. Mountains provide authentic problems that require creative solutions. Mountains affect your relationship with groups and collective decision-making. When climbing with others, safety requires good group decisions. Everyone's input matters, yet decisions must be made efficiently. Your brain systems for social cognition, theory of mind, and consensus building all engage. The dorsomedial prefrontal cortex, involved in social decision-making, works to integrate multiple perspectives. This practice in collaborative decision-making under real consequences strengthens social cognitive abilities. You learn to listen, to contribute, to find consensus, to defer when appropriate, to lead when needed. These skills transfer to all group contexts. Let us explore how the specific challenge of maintaining body temperature in mountains affects your metabolic awareness. Your body works to maintain core temperature. In cold conditions, you generate heat through movement and shivering. Your hypothalamus monitors temperature constantly, adjusting metabolic rate. This gives you direct feedback about your metabolic state in a way that sea-level life rarely provides. You become aware of how different foods fuel you differently, how hydration affects temperature regulation, how clothing choices impact heat retention. This metabolic awareness, this understanding of your body as a thermodynamic system, deepens your embodied knowledge. Mountains influence your sense of freedom and autonomy. In mountains, you choose your path within the constraints of terrain. You decide when to push, when to rest, when to continue, when to turn back. This combination of freedom and responsibility, of choice within real limits, engages your brain systems for autonomous decision-making. Research shows that autonomy, the sense that you are choosing your actions rather than being compelled, is fundamental to psychological well-being. Mountains provide authentic autonomy. The choices are real, the consequences are real, and the freedom is real. The very textures of mountain environments affect your tactile processing and sensory integration. You touch rough granite, smooth ice, soft moss, prickly pine needles, cold water, warm sun-heated rock. Your somatosensory cortex processes this rich array of textures. Each touch provides information about the material and its properties. This diverse tactile input keeps your sensory systems engaged and developing. Sensory processing is not static, it improves with varied input. The mountain provides a natural sensory gym, keeping your touch processing acute and integrated with your other senses. Mountains affect your relationship with momentum and flow states. When scrambling or skiing down a mountain, momentum becomes important. You must flow with gravity in terrain, making rapid micro-decisions. Your brain enters a state of flow, where action and awareness merge. The dorsal attention network and motor systems synchronize, and self-consciousness fades. Flow states are associated with peak performance and deep satisfaction. They require clear goals, immediate feedback, and balance between challenge and skill. Mountain descents naturally create these conditions. Your brain experiences the reward of flow and learns to seek and enter flow states more readily. Consider how the presence of wildlife in mountains affects your sense of connection to the natural world. Seeing a mountain goat navigate impossible terrain, watching an eagle soar on thermals, observing marmots interact in their colonies, all of these experiences activate your brain systems for understanding living things. The superior temporal sulcus processes biological motion. The fusiform face area responds to animal faces. These observations remind your brain that you are part of a larger community of life. This recognition, research suggests, reduces feelings of isolation and increases prosocial behavior. You are not separate from nature, you are one expression of it. Mountains influence your relationship with competence through skill development. As you develop mountain skills, navigation, whether reading, efficient movement, camping techniques, your brain encodes increasing competence. The basal ganglia, involved in skill learning, refine these abilities through practice. Your sense of self updates to include these competencies. This felt sense of increasing capability is psychologically powerful. Self-efficacy, the belief that you can successfully accomplish tasks, grows with each skill mastered. Mountains provide clear domains for skill development with obvious progress markers. The experience of alpine sunrise affects your emotional state through multiple pathways. The gradual brightening, the cool morning air, the stillness before day begins, the often spectacular colors, all combine to create a powerful experience. Your circadian system receives the wake signal. Your visual cortex processes the beauty. Your emotional centers respond to the symbolism of new beginnings. Many cultures across history have considered sunrise sacred, and there may be neural reasons. Morning light after darkness, warmth after cold, energy after rest. These transitions align with psychological states of hope, renewal, and possibility. Mountains affect your relationship with discomfort and your brain's pain processing. Sore muscles, cold hands, tired legs. Mountains involve physical discomfort. But this discomfort is chosen, meaningful, and temporary. Your anterior cingulate cortex, involved in pain processing, distinguishes between this and threatening pain. The context matters. Learning to be comfortable with discomfort, to recognize it as part of the experience rather than something to avoid, builds psychological resilience. Your brain's pain matrix learns to modulate responses based on meaning and context, not just sensation intensity. Let us think about how the specific challenge of limited resources in mountains affects your relationship with sufficiency. You have the food you packed, the fuel you brought, the water you can find or carry. This teaches you about sufficiency. What is enough? Your brain, used to abundance and excess, encounters real limits. The insular cortex, involved in interoception and need assessment, must evaluate, is this enough? Learning to be satisfied with enough, to recognize when you have what you need even if not everything you want, is a profound life skill. Mountains teach it through direct experience. Mountains influence your understanding of exposure and your brain's spatial threat assessment. Standing on a narrow ridge with drops on both sides, your brain must process spatial threat while maintaining function. The amygdala registers potential danger. The ventromedial prefrontal cortex assesses actual risk. The motor cortex maintains precise movement control despite the threat signal. This integration of threat awareness with continued function builds distress tolerance. You learn that you can feel fear and still act effectively. This skill transfers broadly to anxiety management in non-mountain contexts. The practice of observing distant features and planning routes affects your perspective thinking. You look at a distant peak and plan how to reach it. You visualize the route, imagine the challenges, estimate the time. Your frontal pole and rostrolateral prefrontal cortex, involved in perspective cognition and planning, engage intensely. You are practicing mental time travel, projecting yourself into future scenarios. This practice in perspective thinking, with the chance to then execute the plan and see how accurate your projection was, improves future-oriented thinking generally. Your brain becomes better at imagining future states and planning effectively to reach them. Mountains affect your relationship with repair and maintenance through gear care. Equipment degrades in mountain conditions. You must maintain and repair it. This practice in caring for your tools, in anticipating needs and preventing problems, engages your prefrontal systems for planning and foresight. You learn to notice where before failure, to maintain rather than only repair. This orientation toward maintenance over replacement, toward care over disposal, shapes your brain's approach to stewardship generally. You become more likely to maintain relationships, health habits, and other systems rather than neglecting them until crisis. And now, we have traveled together through the mountains of the mind. We have climbed through valleys and forests, across alpine meadows and rocky slopes, up toward summits where earth meets sky. We have explored the countless ways that mountains speak to your brain, the ancient conversation between stone and synapse that has shaped human consciousness for millions of years. But every mountain journey must end with a descent. Not because the mountain is finished with you, but because you must return, changed, to the world that waits. And so now, we descend together into the deepest rest, into the valley of sleep where dreams flow like rivers and consciousness dissolves like morning mist. If you are still hearing these words, still aware of this voice, know that this is perfectly fine. Some journeys into sleep are quick, a sudden step off a cliff into darkness. Others are gradual, a long gentle slope into rest. There is no wrong way. There is only your way, in this moment. Let us walk down together, slowly, peacefully, from the heights we have reached. With each word, you descend a little deeper into rest. With each breath, you release a little more into sleep. The mountain has given you everything it has to offer. Now it releases you into dreams. Think back, if you can, if your mind is still active enough to think, over the journey we have taken. We spoke of serotonin and safety, of ancient brains recognizing high ground as refuge. We explored how altitude changes your chemistry, how thin air creates euphoria through endorphins, how your body adapts with grace and wisdom to the challenge of elevation. We wandered through the colors of mountains, the blues that calm your prefrontal cortex, the greens that activate your parasympathetic rest response. We listened to mountain silence, that profound quiet that allows your auditory cortex to rest and your default mode network to process and integrate. We discovered how mountains create memories through your hippocampus, how novel landscapes encode deeply, vividly. We learned that your brain treats mountain views as rewards, lighting up the same regions that respond to music and love and beauty. We felt how mountains slow time, expanding moments through engagement and attention. We understood how the scale of peaks creates that productive confusion that pulls you into presence. We recognized how climbing increases blood flow to your brain, how it promotes the growth of new neurons and the strengthening of neural connections. We explored stress in mountains, how peaks offer the rare gift of positive challenge, eustress that invigorates without harming. We breathed the clean air with its negative ions, felt our neurons flourish in the absence of pollution. We experienced temperature and light, how coolness sharpens focus through norepinephrine, how darkness promotes melatonin and sleep. We navigated complex terrain, strengthening our hippocampi, improving our spatial memory and problem-solving abilities. We stood small before vastness, feeling awe shrink the ego and activate the vagus nerve. We breathed deeply, diaphragmatically, calming our nervous systems with each full breath. We faced uncertainty in mountains and learned resilience, building our capacity to handle ambiguity. We climbed with others and alone, experiencing neural coupling and shared challenge, finding ourselves in solitude. We reached summits and updated our self-concept, seeing ourselves as capable, as strong, as persistent. We touched ancient stone and felt perspective shift, our immediate concerns shrinking against geological time. We moved through seasons, experiencing how winter light, spring scents, summer warmth, and fall colors each affect our brains uniquely. We encountered biodiversity and felt our brains respond with engagement to the richness of life. We sat in contemplation and felt the boundaries between self and world soften. We solved problems with our whole brains engaged, integration that is profoundly healthy. We managed fear and learned emotional regulation. We saw intense light and felt our visual systems stimulated, our moods lifted. We watched weather change and learned about impermanence. We descended and integrated, processed and consolidated. We understood that mountains live in us even in their absence, that our brains remember and long for that specific state of calm alertness they provide. All of this we have explored together. All of this lives now in your mind, woven into your neural fabric even as you drift towards sleep. The mountain has taught you. Your brain has learned. And now, you rest with this knowledge, this wisdom, settling deep into your being. The descent continues. You are lower now, moving through the alpine zone toward the tree line. The air is thicker here, easier to breathe. Your body relaxes further with each step down, with each word spoken, with each moment that passes. You enter the forest now. The trees close around you like a shelter, like arms holding you safe. The light is gentler here, filtered through branches. The sounds are soft, wind through needles, the distant call of a bird, your own footsteps on the soft earth. You are almost home now. Almost to the valley where sleep waits. Almost to the place where conscious thought dissolves and dreams begin. The mountain is behind you and above you, but also within you. You carry it now. It has changed you, subtly but surely, in ways you will only discover in time. Your brain has received the mountain's gifts. Calm has settled into your nervous system. Perspective has expanded your consciousness. Resilience has strengthened your neural pathways. Peace has permeated your being. And now, as you take the final steps down, as you enter the valley of sleep, you can release everything. Release the day that has passed. Release the concerns that have troubled you. Release even this journey, this exploration of mountains and minds. Let it all go. You are arriving at the trailhead now. The mountain rises behind you, patient and eternal. You have climbed it, or it has held you in imagination. Either way, it has given you what you needed. And now it releases you into rest. Imagine yourself lying down in the soft grass of a mountain meadow. The ground beneath you is gentle, supportive. The air is cool and clean. Above you, stars are beginning to emerge in the darkening sky. Your body is tired in the best way, the way that comes from honest effort, from movement and purpose. Your eyes are closed. Your breathing is deep and slow. Your heartbeat is steady, calm, like the rhythm of the earth itself. You are heavy and relaxed, sinking into the ground, becoming part of the mountain, part of the earth, part of everything. The darkness is complete now. Not frightening darkness, but welcoming darkness, the darkness of deep rest, of safety, of peace. Your consciousness is fading like the last light on a distant peak. First your thoughts grow dim, then your awareness of your body, then even the sense of being a separate self. You are dissolving into sleep like snow melting into a mountain stream. You are becoming part of the larger flow, the current that carries all living things through cycles of waking and sleeping, activity and rest, consciousness and dreams. The mountain has blessed you. Your brain has received its wisdom. Your body has earned its rest. And now you can simply be. Not thinking, not doing, not even listening anymore. Just being, just breathing, just resting in the eternal now. If you are still aware of these words, let them be the last thing you know. Let them be the bridge between waking and sleeping, the gentle hand that guides you across the threshold. You are safe to let go. You are held. You are home. Sleep now, deeply and completely. Sleep like the mountain sleeps, ancient and undisturbed. Sleep like the stone sleeps, heavy and still. Sleep like the stars sleep, distant and peaceful. Your journey is complete. Your rest is earned. Your sleep will be deep and restorative. When you wake, whether in minutes or hours, you will carry the mountain with you. It will live in your neural pathways, in your memories, in the calm that has settled into your being. But that is for later. For now, there is only this, the soft darkness, the gentle breath, the letting go. The mountain is silent now. The valley is still. The night is deep. And you are sleeping. 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 Sleep.